So either you have already observed from a lot of things we've done so far in 5.5. Because we did focus on the sine a lot more than the cosine, right? If you recall from our class last time, so the sine will be, I'll say what most people will prefer to deal with, and also I'm one of them. The cosine is not that much different, right? So now let's make it official. They do name those two functions in the graphs of the sine function, right? Oh, I freeze. So they call it sinusoidal graph. That means the graph of sine here, that's the sine graph. That's the cosine graph, right? You see I didn't name it cosinusoidal, right? Yes, Russell? Good. Well, now think about that. It's very hard for you to tell right away which is sine and cosine because they're so similar, right? They're almost identical, well, except for the fact that, like Russell says, they're just shifted, right? One off the other. So now, think about those questions, without answering it. Just think about those questions. Do those two functions, just by looking at the graphs, have the same amplitude? Do sine and cosine function have the same amplitudes? Yes, right? They have the same height, right? Do they have the same period? Yes, right? Do they have the same domain? Which is negative to positive infinity, so all real numbers, right? Or whatever you call it, but they have the same domain. They have the same range? Yes, right? From -1 to 1. They have the same shape, pretty much, right? Yeah, they have pretty much everything, shared in common. Again, if you want, you can study just the sine graph, but whenever you need the cosine graph, guess what you have to do? You just grab the sine graph. Let's say you're going to find a point to graph, right? Let's say I'm holding the maximum located at pi over 2, and I'll pull it to the left. So I'll be shifting the sine graph to the left by a pi over 2 units, and I'm going to get a cosine. That's all. So you shouldn't be surprised that a lot of things that you know about sine applies almost seamlessly to the cosine, and that it meant to be like that. Okay, and also that's why they call it sinusoidal graph. So now let's see if you guys can quickly figure these basic things out about the cosine graph. I know that I didn't focus too much on the cosine, but I'm sure now you can figure it out since you guys are very good at sine, right? So I'll give you 1 minute for well, yes, 2 minutes. All right, just to be safe. All right, 2 minutes for these two questions. I'm gonna ask the whole class, all right, to tell me what you think. So if you have an answer, keep it to yourself. All right, roughly 2 minutes. I have to look. You got it. Yeah. Good. Good. Yeah. So yeah, that's actually about 2 minutes already. Right. Again, still, if you already show me, that's great. But I do want to see the whole class. You guys raise your hands. Let me know. We're gonna pick for letter. Sorry, number 12. Good. Anyone else? Okay. So I see a lot of ones, a couple of 2, 3s. Right. The answer is A. Right. So now I guess that it is because that ugly coefficient, right? Negative a pi over 7, right? So now, if you're looking at, so real quick, cosine of 2 pi x, can you guys tell me what's supposed to be the period? 1, right? But what about pi over 2 times x? Okay, so now it's getting less intuitive, right? Okay, Manuel, how do you get 2? What divided by? Is that 2 or 4? It's 4, right? So now it's okay because we're not human calculator, right? As long as you know what to do, then you'll make sure that you get it right, in a test. But do you see? So Manuel used the formula. I'm sure that you guys probably recall, right, from the notes. Let's make it official if you haven't been using it. With that ugly b coefficient, right? I think that you should just get a bit more mathematical. Here is 2 pi over the absolute value of the b, right? So now you just plug in and solve for the period, right? 2 pi over the absolute value of negative a pi over 7, which is a pi over 7. So this is what we call a complex fraction, right? So you can do what we call keep, change, flip. You guys remember what that is? Okay, so it'll be 2 pi. It's about dividing it, multiplying the reciprocal, which is 7 over 8 pi. So I hope you realize that the pi get canceled, right? And also the 2 get canceled, so you're left with a 4 on the denominator. So that's why it reads 7 over 4, right? 7/4, right? Okay, so like I said, the only issue is that you guys need to make sure get these kind of questions correct within like a minute or 2, right? So you understand it, and that's why we have the test review worksheet for you to try. And I think that this semester people are doing a lot better because I can solve from, I can see from the quiz, right? And also the first test, right? But we have a second test coming, in a week or 2. I don't know, maybe 2 weeks, something like that. So you guys need to take that test 2 review packet very seriously. Now, 13. Number 13, what are you guys gonna pick? Raise a hand. Let me know if you don't mind. Good. I see almost every hand, right? That's letter D. Yes. So, well, that's trivial, right? So, if we're lucky in a test, we don't see any number in front of X that messing around the scale. You know that it has to be shifting by exactly the same amount. It's gonna be either left or right. But you go by the sign, right? Plus means actually going to the left. That's all, right? And also there will be some absurd options, just to distract you, right? Now, let's see about number 18. I'll give you, again, let's say 2 minutes, right? Because after all, it's a word problem. Right? Go ahead. But don't overcomplicate it. I think that's about. Hmm? All right. So yeah, let's do this. Let me know what you're gonna pick. Okay, good. Good. Yeah. So whoever had a hand up, I think that they all picked letter B. So please remember, even in SAT, when you're dealing with a word problem, especially those questions, that has a long description, right? In this case, not really that bad. Make sure you focus on the question. Make sure you understand what they're looking for. And I hope that you realize the word period is the key word, right? And we're gonna have a test, let's say, about just the graphing part, right? From 5.5 to 5.7, 5.8. I don't know if they will provide it on it, but most likely 5.5 to 5.7. I mean, the period has been the same meaning the whole time, right? It's about a sinusoidal, right? If we use the fancy term, sinusoidal graph. You know that for a sine graph, the period has to be 2 pi divided by the coefficient of the independent variable, right? But I guess that, maybe it isn't a bit confusing that they didn't use the x, right? They use the t. T is the independent variable. If you don't like it, replace it with x. So you're looking at 35 pi as the quote-unquote b value, right? So you're going to divide it out, right? So that will be 2 pi over 35 pi. Pi's cancel, and that's it already, right? There's nothing you can simplify it. So now do you see that? You should see from a lot of the problems in the text review packet, once you figure it out, either we go over it in class, or if you try it, it either worked out in the first place, right? Or it didn't, then you check the answer and you get it. So now you should think, if you have time before the test, what do you think as instructors, why we're picking certain questions in the test? What do we want you to understand and be able to show me? For this question, basically I'm asking you to figure out the period, right, using that formula, right? Or unless you want to really visualize what's going on, because this is a big number, right? So you're squeezing the graph, by so many times. But I think that we're getting to a point when you have a ugly value of the b, then you're better off to use that formula. Okay. Now, all right. Now we're ready for oh, actually, you know what? It's better to first take a look at the textbook. It is a question. Oh, I should have let me see. Is there a way I can? I'll leave it there because it's probably better than writing a whole lot of things. All right, now, so this is actually more realistic in our test when you get a word problem and you think it's hard. It's probably because that either with or without a graph, they are talking about a lot of information, right? You have to understand, what they're trying to, provide you and, how to figure it out. So what's happening is they're trying to understand the tide, right, and the high and low tide, and it's somehow periodic. By periodic, I mean they go up and down, right, in following some certain cycles. So what they told us is the low tide happens at around 4 a.m. High tide happens about 10 a.m. And high tide could be as high as 13 feet, and low tide will be 5 feet. It's periodic. They wanted to find out if you can model this behavior using a sinusoidal graph, right? In this case, they picked the sine function. And don't get me wrong, you could pick the cosine, but obviously you think that maybe sine is a little bit better, more intuitive. And also, if you don't mind, let me be consistent, because in my notes, I like the plus sign here. Okay, that means what I have solved for the C, for the previous class, it's the opposite to whatever they did in a textbook, right? Anyway, so it's gonna be fine. Because I like to see all the plus signs. Anyway, so your goal is to use all the information either from a graph or what they're telling you to figure out what those 4 parameters, A, B, and C, and D. And there's some easy ones, right? I'll say that the easiest one is to find out, it's up to you. I'll say either A or D. Let's first take a look at the D. So forget about the graph at this point. What do you think that the D is going to, in general, do to a graph? If you're adding, or if B is negative, you're subtracting a constant from some kind of graph. It will, yes, Alex? The D, yeah, not B, sorry, letter D. It will move it up and down, right? So now let's see, do you see that the graph? I'm glad that they provided the graph. A sinusoidal curve, which is not fluctuating about the 0 line. You see that? We're so used to, things going up and down about the x-axis. What do you think has happened to the graph? They're going up and down about this line of 9. The graph has been shifted up by 9 units, right? So D is 9. But the thing is, what if they don't get you the graph? Yeah, Russ. So I guess that Russell's concerned about what if, first off, you don't have a graph, or what if the graph is not that clear enough to see where the reference line is? Exactly. They have the dot, so it's going to be 9. What if it's 8.9, right? What if it's 9.1, right? I'll get to that in a second. Mateo? Okay. So Mateo says that, hey, the high tide is 13, low tide is 5. Do you think that the middle will just be the average of the two? Right? Would that be a safer way to find out how much that the graph has been shifted? Because normally you're expecting a graph, let's say if it's a sine graph, going up and down about the 0, right? Let's say if it goes up to 1 and -1, do you see that the average of a 1 and -1 is 0, right? Add them up, divide by 2. So that's the middle, the reference line, the x-axis. But now, if it has been shifted, yes, take the maximum and the minimum, add them up and divide by 2, right? Get the average. And you are getting not only the D, but also the A. Do you see that? The amplitude is not always measured from the 0. It's supposed to be measured from the highest or the lowest to the reference line, right? Which is the middle. So you're looking at how high the high tide is relative to the average level, right? How low the low tide is relative to the average level. So it's going to be 4 for the amplitude, and the D is 9. Those are the easy ones, right? Thanks to the graph, or I think that's not too hard to figure out just by reading it. So now we're left with B and a C. So I'll say that B will still be a bit easier to figure it out than the C. The B tells us something about a period, right? And let's say in this case, there's no reason to go with a negative B, right? If the B is positive, so you want to figure it out what kind of B value such that when you take the period of the entire graph, it will not be 2 pi, and it's going to be 12. So the thing is, what part of the problem indicates the period of the graph is supposed to be 12? It might be kind of obvious, but I want you to know that that's actually something you definitely have to find out correctly. What part of the problem? The graph, or what they're trying to tell you, suggests that you're looking at a periodic behavior of tide with a period of 12. And by the way, it's 12 hours. You guys see it? From, Alex, what do you think? Okay. And that's why they label these 2 points, right? So go about, like getting the, the S shape. But I do share the same concern like Russell had before about the reference line, because it's kind of hard for me to see if, should I start here or here, right? I'll say that the safer way is to go with the peaks or the troughs. So just go find 2 peaks, 2 consecutive peaks. Don't skip one, all right? So from the peak to the next one, see that the first peak is right around 10. The second peak is right around 22. The difference is 12 hours, right? Because the high tide after 12 hours is going to come back. That's all you have to do, right? So now that's why the period has to be tau. So you have to cook up the B to get it, to make it work, right? How would you solve for the B? That's a algebraic question, right? So I want you guys to tell me what would you do to solve for the B. I have 2 pi divided by B equal to 12. What do I do? Okay, good. It's 2 pi divided by 12, not the other way around. You guys see it. It happens so many times I see in the past that students going to do, 12 divided by 2 pi. So that's how it works. You multiply by the B on both sides, right? So the B is going to cancel. Now you're left with 2 pi equals to 12B. You divide out the 12. And the B is going to be pi over 6. Thank you. So I think that this is the algebra that you have to figure out and make sure that there will be a common mistake of a swap in order, right, of the division, right? So now we figure out a B, right, which is going to be pi over 6. The hardest part is the C. And the C tells us something about the phase shift. You can tell that there's a phase shift because the sine graph is supposed to start from the 0, right? And it didn't. It starts somewhere around maybe 6 or 7. Anyway, but before we get to the C, let's understand why this function here has this kind of a fluctuating behavior. Why it sometimes reaches a maximal or minimal. Is it because of the 9? Or is it because of the 4? Those are constants, right? They don't change. What actually changes is actually the sinusoidal behavior, right? Because you plug in different value for x, the sine is going to behave very differently, right? It's going to go about, between, -1 and 1. So that's why if you think that the graph or the entire function reaching the maximum, it's because the sine reaching the maximum, right? Now, when do you think a sine function reaching the maximum? When? At what angle the sine reaching the maximum? Well, do you know what the maximum of the sine is? The range of a sine or cosine is from -1 to 1. The maximum is 1, right? So now you're looking at a very special angle where sine is 1. And 90, right? Or pi over 2, or maybe you have a reference to which I'm going to give you, in the next half of that lesson, then you'll get it, right? So basically, that's why what I did was, look, once I figure out all the remaining letters, right? A is 4, B is pi over 6, D is 9. I say, look, if this piece of a sine needs to be at maximum, so the angle, which is the entire chunk within the parentheses, must be pi over 2, right? But when do you think that the angle is supposed to be pi over 2? It is when the x is, when is the high tide? Oh, right there, right? 10 hour. So let's say when x is the 10 hour, so you're looking at pi over 6 times 10 plus some unknown c, and it needs to be pi over 2. So now you're going to see what kind of c is going to make it work. So you're solving for that constant c, right? Of course, 10 times pi over 6, cross out the 2, you get 5 pi over 3, right? Plus the c equal to pi over 2. Then you're going to subtract both sides by pi pi over 3, you're going to get the c to be negative 7 pi over 6. But of course, I didn't write down, the work to show you the common denominator, but I believe that you should be able to convince yourself that once you subtract these two fractions, keep in a pi, you're going to get something like that. All right. But would you say that, it's a long process, but you should figure it out, the A, the B, and the D with no issue, right? But you have to be, patient with, reading through the information. It is a C that is a little bit involved, right? In algebra. Okay. Now that's something that you already see what's going on, and you can expect what you should get, right? So let's try a problem from the test review packet. Sorry, not test review, textbook. And put yourself in a real world situation, actually in a test situation, right? How would you figure this out? And let's be consistent with our notes. I'm asking you to figure it out, the model in a form of a times sine of b x plus c plus the d. All right, let's go with the plus c instead of a negative c. Right? So the bottom line is, I'll give you 2 or 3 minutes to find out what a, start with the d. The d, the a, and a b. And once you get all of them, maybe think about how you're going to get c, right? But like I said, by the end of the second or the third minute, I want everyone to have, those 3 letters, figured out. The 3 parameters, not letters. Right? Go ahead. Again, the bottom line is you guys need to figure out at least those 3 parameters. Right? Then, if you have time, just give it a try for the letter C. Oh, who has figured out the D? Is that probably the most straightforward part? How much is D, you think? Oh yeah, go ahead, Alex. Oh, sorry. My bad. D, letter D. The vertical shift. North. Oh, you're looking at. So I guess that's some kind of a information. I don't know. That north 30 degree is the latitude, right? So yeah. I don't know. They probably did it on purpose. That has nothing to do with the actual. Well, it does, geographically, right? So that region has a particular, weather pattern, right? Yeah. Anyone figure out the vertical shift? They say the minimum of daylight is 10 hours. The maximum daylight is 14 hours. Minimum is 10, maximum is 14. So how much you think that the graph has been shifted? If it meant to be at 0, right, going up and down. Okay, going up by 12 units, right? It's, again, the average of the two, right? Average the maximum minimum. So D is 12. Now, as soon as you figure out D, how much is A? It's the amplitude. It's going to go from 12, which is the average, up by how much? 2 units, right? And could go down by 2 units. That's why it's 2, right? So now let's see. The B tells us the period, right? And again, let me remind you, the period formula is 2 pi for any sinusoidal graph divided by the absolute value of B. But in this case, the B is going to be positive, right? There's no reason for a negative B. And I demand this is, oh yeah, did they tell us anything about a period for this, like a behavior for the hour of the daylight, the months of the year? Right. So that means the X can only go from 1 to 12 and go around, right? So cycling, so that means, it's 12, right? It's not explicitly, stated, but I hope you can figure it out. So now you just have to cook up the B to make sure that the period is 12 by dividing the 2 pi and by the B. So do you see that B will be 2 pi over 12, which is pi over 6, right? You guys good with that? You know what? I'm not an expert at job. Ask AI if that's, wait, let's see. What is the B? You know what? That might be, yeah. You see that? Because the axis of the Earth is, tilted, right? So what happens is the latitude tells you where the direct point of the sunshine is going to be moving around, right? And I think there's some, yeah, go ahead. So now I'm not sure if it's a happy coincidence, they happen to mesh, but I think that if they're closely related, I shouldn't be surprised. I'm not sure, but I'm seriously thinking that there's a good reason. Because 30 degree, again, I'm trying to remember from high school. But anyway, but that's a good point, right? Now, let's see. What about the C? So once again, we have achieved almost the model, right? Except for the C. So it looks like we have 2 times sine of pi over 6 times x plus the C plus the 12, right? So it's going to be some kind of a sinusoidal graph. But I want, when x is, when do you think the maximum is gonna occur? The June, right? So when x equal to 6, the sine graph will reach the maximum. Okay, that means this whole piece will be 1, but you know that sine of pi over 2 will be at maximum, right? Would you say that it tells me if I take the x to be June, which is 6, right? So pi over 6 times x is 6 plus some unknown constant c, and it better be pi over 2. Because I know that if I plug in x for the 6 and then get this whole angle works out at pi over 2, then the sine is going to be at maximum so that the entire function will be at maximum, right? So now I just have to find what the c is. The number is actually kind of nice. The 6 canceled, right? So you're left with pi plus the c equals to pi over 2, right? Solving for the c by subtracting pi on both sides, so looking at negative pi over 2. Okay, so I think that's, not really as bad as you typically think about a word problem, right? Because I mean the model is easier than you thought, right? When you're trying to use it, it's just that maybe some of the details when it comes to period and the phase shift, right, might not be that straightforward. But I'm sure that if you're able to get, and you should get the constants a, b, and d figured out just by even just reading it, right? Then of course, when it comes to the c, remember that pick the maximum, because that's, when the function is going to reach the maximum, right? Pick the maximum of the sine, and remind yourself that sine is going to reach the maximum when the angle is pi over 2. So you're just thinking that, hey, what kind of a c will make this whole angle become pi over 2 when I demand that x is, the moment when the function reaches the maximum, right? So that's why I plug in a 6, which stands for the June. Okay, so this should be, you know what? I think that if there were a problem like that in the test review packet, I would have picked it, right? But I don't think there was one. So hopefully it says something about the test, maybe not. But I'll say that if I were you, I'll definitely study this example and also the one in the book to make sure that you're able to figure out this modeling kind of a problem. Okay. Now, before I move on to the 5.6, I'll get started. Not trying to finish it, of course, but I do want to get started and also explain to you how to use that reference sheet I just gave you. And tomorrow, we will we'll try to finish the 5.6. It sounds like a lot since you're looking at 4 more trig functions in the graphs, right? But trust me that you are equipped with very powerful tools, which are the graph of sine and cosine. If you understand them, and not to mention that if you understand the graph of the sine better, very well, then you'll be even fine with the cosine, not to mention the remaining 4. Okay. Now, .6. All right, so we're talking about the graph of other trig functions. So let's take this moment to remind ourselves the 4 remaining ones, which are tangent, right, and cotangent, secant, and cosecant. How are they related to the sine and cosine? Can anyone remind us? Well, say secant. Is secant related to what? Cosine. right? Oops. Okay. What about cosecant? So it's going to be 1 over sine, right? So what about tangent? Sine over cosine. And cotangent must be the other way around, right? Yeah. So now, this is like, I'm trying to find, maybe think about, I don't know if it's close related. See, I'm a big fan of tennis. I used to play, but not anymore. But my son plays tennis, for quite a few years. Or now I recently become a big fan of baseball. I wish I can play. Well, I could, but I don't see, how I might be able to play, just by myself. But I've been playing catching, throwing, pitching, right, with my son. So to me, when I see sine and cosine, and I'm trying to picture the whole story about trig functions, I'm thinking about, say, playing tennis. Sine and cosine is like a forehand and backhand. If I know forehand and backhand, I can do anything, right? But of course, when the coach says that, hey, you have good swings, but the thing that bothers you, prevents you from becoming a top tennis player, are your feet. What do you think they mean by that? I have perfect forehand and backhand. I would have been a top tennis player if I had good feet, or they say footwork, right? Because I don't run, and I don't run to the right place. And I couldn't do the perfect forehand and backhand. I can stand there. If you feed the ball to me, I'll do it perfectly, right? Now, the footworks are like the graphing skills, right? So if you know how to graph, you get to, the perfect skills, right? Dealing with the string stretching, shifting around, right? With your knowledge about the sine and cosine, you'll be, perfect with all the trig functions. Baseball, what are the things that you have to worry about? Hit and catch, right? Unless you want to be a pitcher. But typically, if you throw well, you should be fine with catching. But batting is, again, I'm not an expert of baseball, so I think that maybe it might not be, anyway. So do you see that if you know the sine and cosine, you know how to evaluate those graphs, you need to figure out a way to combine the sine and cosine to get a tangent and cotangent. But that's harder than you thought. You have two things going on, right? That's why you see that later on the reference sheet that the graph of the sine and cosine are super weird, right? But take a look at secant and cosecant. And I still want to remind you, maybe I said it in this class once before. One of my third year students asked me, when have I ever used secant or cosecant in my career? And my answer is no, I've never used it in my own research career, right? But I have to teach you guys, I do have to know these, right? So by doing research in physics, and now in this case, right now I'm learning the engineering thing, right? I never used the secant and cosecant. And I kind of see why. Because, anything I want to know about secant, I can get it from a cosine. What would I know about secant? Right? And the same thing happens to the cosecant. But of course, I'm not a mathematician, and I'm not a mechanical engineer, right, or civil engineer. They use those tricks very heavily. If you were to ask, Professor D, he's going to give you a whole story, pretty much everything in the kind of construction field and the road design, whatever, like civil or material engineering, they do a lot of things about the sine and the tricks. And there's a reason that why they define two more functions, even though it seems repetitive if they're based on the sine and cosine, right? But you will definitely appreciate the graph of the sine, the secant and cosecant, because they are so closely related to the sine and cosine. But it's the tangent and cotangent that looks weird. But maybe it's not that bad if you can start take a look at the bottom two graphs on the first page of the reference sheet. Now we'll get to the detail of those graphs. I don't have the time to really do that today. But let's say if you take a look at the first graph on the bottom left graph, which is for the tangent, right? Just take a look. See the graphs, right? Having this kind of a shape, which is kind of similar to a, I think it's like a cubic function kind of thing, right? And it has the two VAs, right? At, I don't know if you can tell, one at pi over 2, the other at negative pi over 2, right? And it's copy and pasted and just extends to, positive, negative infinity. And let me show you question 21 from the test 2 review packet. So let me give you like a minute just to try without knowing how to seriously graph the tangent. Just use the reference sheet, the bottom left graph, which is the standard graph of the tangent. How to match one of those graphs to the function tangent of x plus pi over 2. And tell me which one you feel like picking. Oh, Russell, you have a question? 21. Make sure that. No. Look close. The direction matters. You guys notice that it's pretty much just a phase shift, right? The horizontal shift. To what direction? To the left, okay? So do you see that the graph of letter A matches the standard graph of the tangent? You're going to be shifting this graph to the left by pi over 2. Should it be, wait, what did you say? B or D? Oh, sorry. Yeah, I thought for some reason I heard D. You're right. So it is letter B, right? You guys all see it? Sorry, for some reason I heard letter D. It's as simple as just a simple shift. Do you see that? But the question is there a way we could recreate the reference sheet by going through the logic, understanding, not to mention you don't have a scientific calculator in the test, right? So you better have this kind of reference sheet, maybe ahead of time, and maybe within a couple of minutes you'll be able to recreate it, right? But if you think about that question for one more second, well, SAT provides you the reference sheet, right? And you can use decimals, you can use scientific calculator, right? Then what's the point of remembering it? And I have to say that it's hard because if I don't have to teach it, right? If I go on the street and ask anyone, right, hey, do you know the graph of the tangent function? What does it look like? 9 out of 9.9%, or let's say 9 out of 10, right? 9 out of 10 people won't know what the graph of the sine and cosine function look like, right? Even if you ask, a math professional, for example, like the programmer from Apple, right, or some kind of a electrical engineer, not necessarily mechanical engineer because they don't use that much of a tangent stuff, right? So electrical engineer, they use sine and cosine a lot. Say, tell me within a second what the tangent graph look like. They will hesitate. So now, this is why I'm printing this out. What you should do is, instead of trying to memorizing it right before the test, use it, right? Play with those problems in the test review packet, and hopefully use those homework problems to 5.6, right? To get used to these facts, and maybe later on, they're not just those random facts.